Hello everyone, I hope all you are doing very good in your life. Today in this video we are going to derive an equation for particle in a box. That means we are going to find out a wave function when particle is in potential well. Okay, so before I am going to derive an equation for this, most of the student will get confused. For example, there is one question called obtain the solution of Schrodinger time independent wave equation when applied to a potential well of infinite well. See, while most of the students, when they saw this question, they got confused whether they need to derive an equation for time independent part of the Schrodinger equation or a potential well equation, and most of the time they will get confused and they will try to solve the Schrodinger time independent equation only. So please read out the question, understand it, and then go for a solution. Okay, so let's start the derivation part for a particle in a box. Famously, we can say that this is an application of Schrodinger wave equation. Sometimes they may ask you to derive an equation for particle in a infinite potential well, then that is also same. Particle in a box, that is also same. And as I mentioned in this question, obtain the solution of Schrodinger time independent wave equation when applied to a potential well of infinite height, that is also same. Okay, so before I am going to start the derivation, I would like to request you to subscribe to my channel, like and share with your friends. Okay, so let us start the derivation part. Now the Schrodinger time independent equation must be applied infinite potential well, as we can see here. Why we need to say infinite potential well? Well, that means before x equals to 0, the potential energy V is maximum, or we can say infinite. So due to that reason, kinetic energy before x equals to 0, there will be 0, and due to this reason psi wave function definitely will become 0. Same like that here also, V is maximum and kinetic energy is equals to 0, and due to that reason psi is also 0. So what is the difference between kinetic energy and potential energy? See, whenever we say potential energy is more, then the system is under rest. When we said kinetic energy is more, then that system is under motion. Okay, so with respect to this, if we apply the same concept here, outside the potential well where potential energy is maximum, due to that reason kinetic energy will become 0. If kinetic energy will become 0, that means outside the potential well there is no possibility of finding an electron or any wave equation. So that is what it's trying to tell the diagram. But what about inside the potential well? Inside the potential well, V will become 0. If potential energy will become 0, then kinetic energy definitely will not become 0. That means psi wave function is also not become 0. We are going to find out the wave function when the particle inside the well. Okay, before we are going to derivation, there are two parts. One part is utilized to find out the eigen values, and another part is to find out the wave function. So first we will try to find out the wave function, and then we will find out the eigen values with respect to particle in a box. As we mentioned in above, let us take or write Schrodinger time independent equation. We know that d square psi by dx square plus 8 pi square m divided by h square into E minus V V into psi is equals to 0. This is a time independent Schrodinger time equation. Okay, now as we know that there are two conditions, one is outside the potential one and another one is inside the potential one. Let's try to find out the equation for outside the potential well. So in that case, potential energy is more nothing but infinitely high, and at the same time psi will become 0. In that case, above equation will be vanished because psi is here, V will be infinite. So if we multiply psi is equals to 0, then the equation will be vanished. So due to that reason, we can't be able to find out the equation in outside the potential well. So that is the first condition. We saw that. Next, see second condition. Here when we are at inside the potential well, where V is equals to 0, okay, and psi we don't know, that is must be find out by using this derivation. So let us apply in this equation. We can write it as d square psi by dx square plus 8 pi square m divided by h square into E into psi is equals to 0. Because V will become 0, then we can directly write this equation. Now see, by using this equation we can write where k square is equals to 8 pi square m divided by h square. If I substitute in this equation, then this equation will become d square psi by dx square plus k square into E psi is equals to 0. So keep this equation, very important ones, inside the box. Okay, now let's see the next part of the derivation. See, usually mathematically we can say this is the end of the equation, but with help of the physics you can't say whatever that equation is here is equal to 0. If we say equal to 0, then the entire equation will be vanished or entire process will be disturbed. To explain that, you can imagine, for example, d square psi by dx square. In properties of wave function, we know that double differentiation of anything must be continuous. Means if I take psi is equals to x, if I substitute here double differentiation of this one, if I differentiate first time, I will get 1 with respect to dx. If I again differentiate this one, what I will get? 0. That means this side of the equation will become 0. That means k square E psi is become 0. Now k should not be equal to 0 because k belongs to energy, and we know that particle is present inside the potential well. We must try to find out the energy of the particle, but here as per mathematical equation, when we try to solve it, we got that k square is equals to 0. It should not be continue like this. Before that, we can say by taking the help of another equation, that is psi of x equal to c cos kx plus d sin kx. With the help of this equation, we need to continue the derivation. Before we apply the x equal to whatever the value is, let's see here. There are two x values. One is x equals to 0 and x equals to a. X equals to 0 when psi is equals to 0, x equals to a when psi is equals to 0. So let's apply in this equation for the first condition where x equals to 0 and psi is equals to 0. That means I am here at x equals to 0 when psi is equals to 0. When we substitute in this equation, then we got x equals to 0, so cos 0 will become 1 and sin 0 will become 0. That means, and psi of x is equals to 0, so 0 equals to c plus 0. The ultimate equation is c is equals to 0. So keep it inside the box and name this equation as equation number 1 and this one is equation number 2. Now next, come here at x equals to a when x psi is equals to 0. Substitute in this above equation 2. We got for second condition, we can say that x equals to a and psi is equals to 0. If I substitute in equation number 2, we got, as we know that psi is equals to 0 is equals to c cos ka, because x equals to a plus d sin ka. Okay, so c, here we already know that c is equals to 0. That means substitute here c is equals to 0, then this entire term will become 0. In that case we left only this one. So write down once again d sin ka is equals to 0. So keep it inside the box. This is also an important term in this derivation. Okay, now once again we are in the trouble. Why? Once again we got mathematically we said d sin ka is equals to 0. d must not equals to 0 and ka is also not be 0. So to avoid this equation, if we consider equals to 0, then entire whatever we are trying to solve the derivation, it will be vanished and it will be waste of time. So to avoid that, we will consider one value, that is ka is equals to n into pi, where n is the quantum number, that is 0, 1, 2, 3, so on. Okay, so if I substitute like this, then we can say k is equals to n pi by a. So keep it inside the box because this is also an important term, and name it equation number 3. So we got the equation k is equals to n pi a and c is equals to 0. Substitute all this in equation number 2. Then we can write where psi of x is equals to c is equals to 0, then c cos ka or cos kx will become 0. So only the left part is d k sin kx. So substitute here and we got d sin, instead of k we can write into bracket n pi by a bracket close into x. Okay, now we need to understand that, so keep it inside the box and let's back to the diagram. See, here we know that at least one electron or one wave equation must be found in this potential well. So now because of that reason we can apply this equation in normalization condition. Then what is the formula for normalization? We said integration modulus square of psi d tau is equals to 1. This is the equation for normalization. So substitute this here, and d tau is related to the volume, and here we consider the volume which is related to x, because particle is under x-axis direction, particle is moving in x-axis direction. So we can convert this formula with respect to this situation. Then we can write integration mod square of psi is, we can write it as t square sine square into n pi a into x dx is equals to 1. Now it is very easy to solve the equation, because integration, you know that it is very easy and it is constant. Whatever the constant term is there, keep it outside, and integration is very easy to you people to solve this. So let us see the integration part solution. So we know that when sine square theta is there, we can write it as 1 by 2 into 1 minus cos 2 theta. So the same thing applied here. In that case, integration d square, keep it outside. Okay, so sine square theta will become 1 by 2 into 1 by 2 into, if I substitute here, 1 minus cos 2 n pi by a x into dx equals to 1. Okay, now if I integrate this equation, what I will get? 1 by 2, keep it outside, that means t square by 2 into 1, this dx term will be multiplied here, dx minus cos 2 n pi by a x dx is equals to 1. Now integrate the equation, we get t square by 2, dx integration will come x minus 2 n pi a will become a by 2 n pi into cos term will become sine 2 n pi by a x into 0 to a is the limit. Why we take this limit? Here we already have a limit in between 0 to a, so I forgot to mention that. So this is the 0 to a limit. Substitute here, we got ultimate answer is t square by 2 into a minus a by 2 n pi sine 2 n pi a into a get cancel is equals to 1. Next, the ultimate equation, when sine 2 n pi will become 0, then ultimately this part of the equation will become 0. The remaining part of the equation is t square divided by 2 into a equals to 1. In that case, we can take d is equals to under root 2 by a. So important part of the derivation. So we got the d value. So this one substitute in here, where d sine n pi a x. So if I substitute, and we can write the ultimate value of psi is equals to under root 2 by a sin n pi by a. This is the final equation for derivation. I hope you got to know what I tried to explain here. This is the end of the derivation with respect to finding an equation for psi. In the same derivation, we need to find out the energy eigenvalues. For that, we'll see now. Previously, the particle in a box derivation only we have to derive this equation. Okay, so let us start the derivation part. Initially, the same Schrodinger time independent equation must be considered, where d square psi by dx square plus 8 pi square m divided by h square into e minus v into psi is equals to 0. Here the same condition, v is equals to 0, we have to substitute here. V means potential energy is equals to 0, we have to substitute here. In that case, we got this equation. So while this, we have to take it as k square is equals to 8 pi square m by h square into e. So if I substitute here, the equation will become like this. Okay, and now let us take this equation, k square is equals to 8 pi square m by h square into e. So take this equation and we can write it here, where e is equals to h square k square divided by 8 pi square m. Can I write it like this? We just send e 8 pi square m by h square this side. So in the previous video, we already got the k value, where k is equals to n pi by a. So substitute here, then we can say e is equals to n square pi square h square divided by a square 8 pi square m. So pi square will get cancelled, then e is equals to n square h square divided by a square 8 m. This is the energy eigenvalue. Sometime in the question paper, he used to ask you to find out the 0 point energy. Try to understand. N means quantum number. We said 0, 1, 2, 3, so on. So n equals to, we can substitute 0, 1, 2, 3. What is the minimum number must be substituted here? If I say 0 here, then energy will become 0. That means this energy, if energy will become 0, then particle will be absent. Particle, it is not possible to find out the particle. So that's why we must not take 0. Minimum value must be taken from 1, 2, 3, so on. So that means if I take n equals to 1, then above equation will write it as eigen energy for 0 point is equals to h square by a square 8 m. This is the equation for 0 point energy. That's it. This is called energy eigenvalues for given equation, that is Schrodinger wave equation. And sometimes this separate part may be asked. For example, find out the 0 point energy or define the 0 point energy. In that case, you need to write this part of the explanation. I hope you got to know what I tried to explain it here. Please subscribe to my channel and like and share with your friends. With this, let's wrap up the video. Thank you.